In this video, you will learn how to solve quadratic equations by factoring. The tutorial is divided into two parts. In the first part, we will solve two-term quadratic equations using techniques like the greatest common factor and the difference of two squares formula. In the second part, we will solve quadratic trinomials, both with a leading coefficient of 1 and different from 1. We will use techniques like the product sum method, the AC method, and factoring by grouping. Towards the end, we will cover quadratic equations given in non-standard form and also address the most common mistake made when solving quadratic equations. Let's get started. In our first three examples, the constant term of each quadratic equation is missing. In such cases, our first step is to factor out the greatest common factor from each term. In this example, the GCF of x squared and negative 10x is x. This is one of the factors of this equation. The other factor is just the sum of what is left here, which is x minus 10. Next, we will apply the zero product property. But first, what is this property? The zero product property states that if the product of two factors is equal to 0, then at least one of the factors must be 0. For instance, if the product of a and b equals 0, then either a is 0 or b is 0. Similarly, for this product to be equal to 0, either x must be 0 or x minus 10 must be 0. The next step is to solve for x. For the first equation, x is already equal to 0. For the second equation, add 10 to both sides to isolate x. These cancel out, and we get x equal to 10. Therefore, the solutions are x equals 0 or x equals 10. We can check our solutions by substituting them back into the original equation. Substituting 0 squared is 0, 10 times 0 is also 0, and the difference is also 0. Likewise, substituting 10 squared is 100, 10 times 10 is also 100, and the difference is 0. As you can see, both 0 and 10 check out, confirming that they are indeed solutions to the quadratic equation. Let's work on another example like this. As we did in the previous example, first, we factor out the GCF from each term. The GCF of the numbers is 3, and that of the variable is x. So, the GCF of the two terms is 3x. The other factor is the sum of what remains here, which is x plus 5. Now using the zero product property, for this product to be 0, either 3x must be 0 or x plus 5 must be 0. Then, solve for x. For the first equation, divide both sides by 3 to isolate x. These cancel out, and we get x equals 0. For the second equation, subtract 5 from both sides to isolate x. Therefore, the solutions are x equals 0 or x equals negative 5. Now is your turn. Please pause the video and give it a try. First, factor out the GCF from each term. The GCF of the numbers is negative 4, and that of the variable is x, right? So, the GCF of the two terms is negative 4x. The other factor is 2x plus 3. Next, set each factor equal to 0 and solve for x. From the first equation, we get x equals 0. For the second equation, first subtract 3 from both sides to isolate 2x. Then divide both sides by 2 to isolate x. Therefore, the solutions are x equals 0 or negative 3 halves. In the next four examples, the middle term of each quadratic equation is missing. In such cases, we will use the difference of two squares formula to factor the equations. The difference of two squared values is equal to the product of the sum and the difference of the values. In this example, 81 is a perfect square and can be written as 9 squared, right? As you can see, this is now the difference of two squares, and we can factor it as x plus 9 times x minus 9. Now we have completed factoring. Next, using the zero product property, we set each factor equal to 0. Then, solve for x. Solving the first equation, we get x equals negative 9. Solving the second equation, we get x equals 9. Therefore, the solutions are x equals negative 9 or positive 9. In the next example, the leading coefficient is negative, and the constant term is positive. In this case, factor out the negative sign to the front, making the equation suitable to be factored by using the difference of two squares formula. Now, the expression inside the parentheses can be factored as x plus 7 times x minus 7. Next, apply the zero product property. For this product to be 0, either x plus 7 must be 0 or x minus 7 must be 0. From the first equation, we get x equals negative 7. From the second equation, we get x equals 7. Therefore, these are the solutions. In the next example, the constant term is not a perfect square, which might make it seem difficult to apply the difference of two squares formula. However, since 7 is a factor of 63, we can factor it out, making the constant term a perfect square. In fact, a general tip when solving quadratic equations with a leading coefficient different from 1 is to begin by factoring out the greatest common factor. This simplifies the factoring process. Now, apply the zero product property and solve for x. Subtract 3 from both sides of the first equation, and add 3 to both sides of the second equation. Therefore, these are the solutions. Now it's your turn. Please pause the video and give it a try. In this example, 9 and 25 do not have a common factor, but both are perfect squares. You can rewrite 9x squared as 3x squared and 25 as 5 squared. This is now a difference of two squares, and it can be factored easily, right? Next, set each factor equal to 0 and solve for x. By the way, these types of quadratic equations can also be easily solved using the square root property. Please make sure to check the link in the description after you finish watching this video. Now, let's move on to solving quadratic trinomials. We begin with equations that have a leading coefficient of 1. In such cases, our first step is to find two numbers that multiply to give the constant term and, at the same time, add up to the coefficient of the middle term. In this example, the constant term is 24, and the coefficient of the middle term is 11. So, we need to find two numbers that multiply to give 24 and add up to 11. To find these numbers easily, we start by listing the factor pairs of 24. 1 and 24. 2 and 12. 3 and 8. 4 and 6. We also have the negative factor pairs, which can be obtained by changing the sign of these factor pairs. Now we have a list of all pairs that multiply to give 24. Next, we need to figure out which pair adds up to 11. Let's add them to find out. 1 plus 24 equals 25. 2 plus 12 equals 14. 3 plus 8 equals 11. We have found the numbers. It is the pair 3 and 8, right? There is no need to check the remaining pairs, as only one pair satisfies both conditions. Therefore, as 3 and 8 are the two numbers that multiply to give 24 and add up to 11, when we factor this quadratic equation, it becomes x plus 3 times x plus 8, which equals 0. At this point, we have completed factoring the equation. The next step is to apply the zero product property by setting each factor equal to 0. Then, solve for x. Solving the first equation, we find that x equals negative 3. Solving the second equation, we find that x equals negative 8. Therefore, the solutions are x equals negative 3 or negative 8. We can check our solutions by substituting them back into the original equation. Substituting negative 3 squared is 9, and 11 times negative 3 is negative 33. 9 minus 33 is negative 24, and this equals 0, right? Similarly, substituting negative 8 squared is 64, and 11 times negative 8 is negative 88. 64 minus 88 is negative 24, and this equals 0. As you can see, both negative 3 and negative 8 check out. Let's work on another example like this. Similar to the previous example, the leading coefficient of this quadratic equation is also 1. So, the first step is to find two numbers that multiply to give the constant term and add up to the coefficient of the middle term. To find these numbers easily, first, list the factor pairs of negative 36. 1 and negative 36. 2 and negative 18. 3 and negative 12. 4 and negative 9, 6 and negative 6. By changing the sign of these factor pairs, you can obtain the other half of the factor pairs. Now, you have a list of all pairs that multiply to give negative 36. Next, figure out which pair adds up to negative 5. Simply add the pairs to find out which one it is. It is the pair 4 and negative 9, right? As I mentioned before, there is no need to check the remaining pairs. Only one pair satisfies both conditions. Therefore, as 4 and negative 9 are the two numbers that multiply to give negative 36 and add up to negative 5, when we factor this quadratic equation, it becomes x plus 4 times x minus 9, which equals 0. Next, set each factor equal to 0 and solve for x. Solving the first equation, we find that x equals negative 4. Solving the second equation, we find that x equals 9. Therefore, the solutions are x equals negative 4 or 9. In the next example, the leading coefficient is not 1. What should we do in such a case? When the leading coefficient is not 1, our first step is to check if we can factor it out. In this case, the leading coefficient is negative 1, and it can be factored out easily. Simply change the sign of each term and place the negative sign in front of the parentheses. Now, the expression inside the parentheses has a leading coefficient of 1, so you can follow the same steps as in the previous two examples. Please pause the video and try factoring the expression inside the parentheses. Find two numbers that multiply to give negative 42 and add up to 11. List the factor pairs of negative 42. 1 and negative 42. 2 and negative 21. 3 and negative 14. 6 and negative 7. Changing the sign of these factor pairs gives you the other half. Now, all these pairs multiply to give negative 42, but only one of them adds up to 11. Which one is it? It is only negative 3 and 14, right? Therefore, these are two numbers we are looking for, and the expression inside the parentheses can be factored as x minus 3 times x plus 14. Now for this product to be 0, either x minus 3 must be 0 or x plus 14 must be 0. Solving the first equation, we find that x equals 3. Solving the second equation, we find that x equals negative 14. Therefore, these are the solutions. Let's work on another example like this. In this case, the leading coefficient is 3, which is a common factor of both 27 and 60. Therefore, we can factor it out. Now, the expression inside the parentheses has a leading coefficient of 1. From our previous examples, you know the process of factoring this, right? Feel free to pause the video and give it a try. Find two numbers that multiply to give 20 and add up to negative 9. List the factor pairs of 20, 1 and 20, 2 and 10, 4 and 5. Change their sign to obtain the other half. Now, all these pairs multiply to give 20, but only negative 4 and negative 5 add up to negative 9, right? Therefore, the expression inside the parentheses can be factored as x minus 4 times x minus 5. Now for this product to be 0, either x minus 4 must be 0 or x minus 5 must be 0, right? From the first equation, we find that x equals 4. From the second equation, we find that x equals 5. Therefore, these are the solutions. In this example, factoring out 3 made the leading coefficient 1. However, in the next example, we cannot factor out 5 because it is not a common factor of both 18 and 9. In such cases, start by multiplying the leading coefficient by the constant term. In this example, the leading coefficient is 5, the constant term is 9, and their product is 45. Then, find two numbers that multiply to give this product and add up to the coefficient of the middle term. So, you need to find two numbers that multiply to give 45 and add up to 18. List the factor pairs of 45, 1 and 45, 3 and 15. If you notice, 3 and 15 add up to 18, right? So, these are the two numbers we are looking for. While listing the factor pairs, If you notice a pair that works, you don't need to continue listing the remaining pairs, since there is only one factor pair that satisfies both conditions. Moreover, if you can mentally figure out the two numbers, there is no need to make a list. You can proceed with that. And by the way, because we are multiplying A by C here, this method is called the AC method. The next step is to split the middle term using the two numbers we found. We can rewrite 18x as the sum of 3x and 15x. If we add these terms back together, we get the original 18x. So we are not changing the value of the equation. The other terms in the equation stay the same. Next, we factor by grouping. Group the first two terms together and the last two terms together, then factor out the greatest common factor from each group. In the first group, the GCF is x, which is one of the factors of this group. The other factor of this group is simply the sum of what is left here, which is 5x plus 3. In the second group, the GCF is 3, which is one of the factors of this group. The other factor of this group is the sum of what remains here, which is again 5x plus 3. When you factor by grouping, if the factors inside the parentheses are the same for both groups, then you are on the right track. Otherwise, you need to go back and check your previous steps. Next, factor out the common factor for both groups. This leaves behind x plus 3 as the other factor. Now we are done with factoring. The next step is to set each factor equal to 0 and solve for x. Solving the first equation, we find that x equals negative 3/5. Solving the second equation, we get x equals negative 3. Therefore, these are the solutions. In the next example, the quadratic equation is not in standard form. What should we do first? In this case, the first step is to rewrite the quadratic equation in standard form. To do this, subtract 43x from both sides of the equation. Now, you have a quadratic equation in standard form with a leading coefficient different from 1. Since 18 is not a common factor of both 43 and 5, it cannot be factored out. Therefore, you need to use the AC method, as in the previous example. Please feel free to pause the video and give it a try. First, multiply the leading coefficient by the constant term, which equals negative 90. Then, find two numbers that multiply to give negative 90 and add up to negative 43. List the factor pairs of negative 90. 1 and negative 90. 2 and negative 45. Notice that 2 and negative 45 add up to negative 43, right? Now, as we have already found the two numbers we are looking for, there is no need to list the remaining factor pairs, so we can proceed to the next step, which is to split the middle term using these two numbers. You can rewrite negative 43x as the sum of 2x and negative 45x. The other terms stay the same. Next, factor by grouping. Group the first two terms together and the last two terms together, and then factor out the GCF from each group. In the first group, the GCF of the numbers is 2, and the variable is x, so the GCF is 2x. Notice that here, 2x is the same thing as 2x times 1, so the other factor of this group is 9x plus 1. In the second group, the GCF is negative 5, leaving 9x plus 1 as the other factor. Notice that the factors inside the parentheses are the same for both groups, indicating that you are on the right track. Next, factor out 9x plus 1, which leaves 2x minus 5 as the other factor. Finally, apply the zero product property by setting each factor equal to 0, and then solve for x. Solving the first equation, you find that x equals negative 1/9. Solving the second equation, you find that x equals 5/2. Therefore, these are the solutions. Let's solve our last equation, which has only one solution. When a quadratic equation is given in this form, please avoid setting the factors equal to the number on the right side of the equation and solving for x. This is a common mistake. Remember, the zero product property can only be applied when the product of the factors is 0. In this example, the product of 4x and x minus 5 is negative 25, which is not 0, therefore the zero product property cannot be applied in this form. So, what should we do first to solve this equation? Because this quadratic equation is in non-standard form, the first step is to rewrite it in standard form. To do this, start by distributing 4x. 4x times x is 4x squared. 4x times negative 5 is negative 20x. Then, add 25 to both sides of the equation. Now, you have a quadratic equation in standard form, and your next step is to factor it. Since 4 is not a common factor of both 20 and 25, it cannot be factored out, so you need to use the AC method. First, multiply 4 by 25, which equals 100. Then, find two numbers that multiply to give 100 and add up to negative 20. Let's do this mentally. Try to think of two numbers that satisfy both conditions. You know that 10 times 10 is 100 and 10 plus 10 is 20. But if you make both 10s negative, the sum becomes negative 20, and the product is still 100, right? So, you have found the two numbers. The next step is to split negative 20x using these numbers. The other terms stay the same. Next, factor by grouping. Please pause the video and give it a try. In the first group, the GCF of the numbers is 2, and that of the variable is x. So, the GCF is 2x. The other factor is 2x minus 5. In the second group, the GCF is negative 5, and the other factor is, again, 2x minus 5. Now, factor out the common factor, which is 2x minus 5. As you can see, the other factor is also 2x minus 5. When we set each factor equal to 0 and solve for x, we find the same solution. So, this quadratic equation has only one solution. In general, when you factor a quadratic equation and obtain the same factors, it implies there is only one solution. This typically occurs when the trinomial is a perfect square. Thanks for watching. I hope you found this video helpful. Please give it a thumbs up and consider subscribing. If you have any questions, please feel free to leave them in the comments below. I will do my best to answer them.